Guys, welcome to this new video. Today we are going to solve another exercise under circuit analysis, and here you have on the board a diagram. We are calling for you to prove that V is equal to E Thévenin minus I times R Thévenin. So the aim of this exercise is to evaluate the E Thévenin as well as R Thévenin. The first thing that I'm going to do is to give the direction of each current as well as the direction of each voltage. We discover that the current flowing through the resistor, this first resistor, will be equal to the V at the higher potential minus V at the lower potential divided by R. So we can simply say that the current flowing here will be equal to E minus V divided by R, as well as the current flowing here, because this voltage source is dependent voltage source, because the voltage across this source depend of the voltage across this resistor R. So the direction of current will be looking up like that, and in that regard the current flowing through that resistor will be V at the higher potential, which is here the output voltage, V minus K U divided by R. Okay, as well as the current flowing through this resistor here is only the resistor. The direction will be let's say the direction will be up, like that. Let's say, because this resistor is consuming is a receptor, means that the current will be going down. The computer is disturbing so much. The current will be going down, and that current will be equal to V divided by R. So now, and in this junction, if you apply the first law of Kirchhoff, we can simply write that the sum of the current leaving the junction should be equal to the sum of the current going inside the junction. We can say the current going here will be equal to this first current, this one, minus this other one. So we can simply write E minus V on R minus V minus K U divided by R. Don't forget the bracket. Okay, as we wrote it like that, if you reach now in the second junction, junction B, we apply the same law, the first law of Kirchhoff at junction B. You can simply give the expression of I. We are going to write like this. In junction B, we can simply write I, which is the output current, will be equal to the main current, E minus V on R minus V minus K U on R. Now minus V on R again, minus V on R. That is all. Don't forget that direction, as well as the voltage flowing through this closed loop. If you apply the second law of Kirchhoff, this closed loop, you have loop 1 here. If you apply, let's say we give the direction of each voltage. Here is U and here is E, as well as here the voltage across this branch is equal to V. If you apply the second law of Kirchhoff, you can simply write E is equal to U plus V. This implies that the unknown point here, U, is equal to E minus V. Let's say we call this equation 2 and this other one equation 1. Now if you take equation 2 into equation 1, you can express the expression of I in terms of E, V and R, and as well as K. Let's say we arrange that thing very well. We discover that up there I alone will be equal to E minus V minus V plus KU minus V all over R. Okay, there's nothing to speculate in this formula. I hope that you will be able to demonstrate like that. Now, if you take this term produit des extrêmes égale au produit des moyens, we are going to obtain something. Let's say here you have 1. You take I times R will be equal to E minus V minus V plus KV minus V. That is it. KU, not V. KU. Now let us replace this item by his own value that we have up there and see what we are going to have. Means that let me change the color, pen color, means that I times R will be equal to E minus V minus V again, let's say minus 2V plus K bracket open U equal to E minus V bracket close minus V again. Now we have something. Let us arrange it very well. Here I have let us open this bracket here, so we can write like this. E, I have here item V. That will give us minus 3V minus 3V. That is it. Plus KE minus KV. Okay, this is here I times R. Let us arrange it very well again, because I discovered that I have a term item V here as well as here. This implies that I here is I times R will be equal to E minus V. I have the item V. Let us say V in bracket open. Here you will remain. I have a 3 and V. This implies that, let's say I put the V plus 3. I hope that I have not changed anything. And here as well as here, I was having also the common factor here, this one and this one. Let me say that. Let me take it back again. I was saying that I have the common factor here as well as here. So we are going to have a E bracket open. Here we take K first plus 1 minus V bracket open V, let's say V, it will remain K plus 3. I hope that I have not changed anything. And when we reach in this step now, the given expression was to prove that V is equal to ETF minus. We are going to find that expression here. If we look now, the expression of V alone, the expression of V alone in this equation, we give up V bracket open K plus 3 will be equal to, let's say send it in the other hand, will be equal to E K plus 1 minus I times R, and the unknown point that I'm looking for here is this item. If we take it very well, we can write V alone will be equal to K plus 1 E divided by K plus 3 minus I R divided by K plus 3. If you have a question, don't forget to ask me in the description section below. I hope that we don't have any problem here. And if you compare this equation that we just calculate now, we discover that in the given expression was V equal to E Tef minus I times R Tef. Now, by identification, you discover that this item is equal to this item, as well as this item is equal to this other item. We can simply write with that speculation and say that E Tef is equal to K minus 1 on K plus 1 divided by K plus 3 multiplied by the supply E, and R Tef by identification is equal to R divided by K plus 3. That was all about that exercise. That exercise. If you have a question, don't forget to ask in the description section below. And if you are new in this channel, don't forget to subscribe so that you will not lose the portion video. Switching guard for watching. Don't forget to subscribe. Have a nice day and Happy New Year once more. Ciao.